Hey guys, so I decided to make one today. Found out some more confirmation on my theory, but first let me show you just to go 16 east. Natural color full disc. Put it on the largest number, smallest number here. And as you can see, we still have the object reflecting, being recorded by this GOES 16 satellite, reflecting light, albeit it's getting further and further away from the satellite. So, is it getting closer to Earth? Hard to say, but I would say yeah. The way things have been going, why not? So if you've been following me for any length of time, the last few vids I put out, I threw up my hypothesis, which I still say stands. And you can pause this and read that if you want, or I'll copy and paste it and put under this next video. But here we go. Check this out. This is the last 24 hours on ACE. Get the little gap between 1900 and 2100. And then between, close to 2200. About an hour gap there, maybe less. I didn't realize this existed before, or I would have pulled it up, but I don't think it really would have mattered. Because I think that big blocking occurrence that lasted for 6 months or more, beginning when I started to identify it way back in early part of 2018. Started out at 4 to 5 hours where you didn't have any data coming from ACE, and then it grew to as much as 9 hours, and then all of a sudden it passed ACE, and then it started showing up the gap on Discover. So here I pulled up, this is all they give you, the last 48 hours and the last 6 hours. This is on the ACE ground tracking stations. And as you can see, these are a summary of all the stations down here, and you can see that there's the gap between 19 and 2100. ACE was not able to, or these Earth ground tracking stations, which are all located on the planet. There's a list there. And then there's the other gap, corresponds exactly to these two gaps. So, whatever passed ACE, well, the big 12-hour one passed. And then there it is here on the Discover ground tracking station. It's like a 12-hour block of time where they got no data on the 25th. Come on. And there it is, the 12-hour block of time on the 25th. And then on the 27th, we got this smaller one. You can see the time will flash up here. So it started about 2:08. So it's like almost 2.5 hours gap on the 27th. So let's see. There it is. So here's the deal, guys. Whatever it was that was blocking, and I submit has to be planets. They've passed the ACE and the Discover satellites out here at the L1 Lagrange position, which is 930,000 miles in front of the Earth, between the Earth and the Sun. Of course, this isn't to scale. The Sun's way, way further out there. So they're incoming. We got one that made a 12-hour data gap on the 25th on Discover, but now I imagine it's passed far enough from Discover that now that there's no disruption in the data relay. And the couple smaller ones, 2 and 1 hour respectively, still blocking some ACE data, and it looks like picked up 2-hour one here on Discover, blocking some Discover data. So I'd say we have at least 3 incoming objects, 1 large planet and perhaps 2 moons or whatever. We already have 1 fairly large planet, I'd say, that's penetrated below our geosynchronous orbit, which is 22,236 miles above the Earth, where these GOES 13 and 14 satellites go round and round, and that's what gives us all this data here. This isn't coming from ACE or Discover. And then the GOES 16s may be parked here, and the Himawari over here, or vice versa, recording the west and the east sides of the Earth continually for weather. Basically for weather. So, I mean, anybody that's awake at all knows that there's been many credible sightings of objects up in our skies. So I would submit to you that they are getting dangerously close at this point. And the space weather here would bear that out as well. Watch these numbers here. That's solar wind speed. And remember, this is all being recorded from these satellites within that 22,000 mile, 236 mile orbit. And the space weather is looking pretty violent. Okay, we keep coming down here. We're going to hit over 1,000 kilometers per second. There we go. That's really high. Normal is 400 to 700 measured coming from the sun, which is only measured on ACE, of course, or Discover. So all these solar wind numbers coming in here, which are extremely high, are all coming from Nemesis behind the Earth, because you can see the solar wind speed here is right around 400 kilometers per second on ACE and on Discover. Actually, it's, yeah, so topped out around 420, something like that. So, I mean, it's not looking good, folks. These are the radiation belts recording all the electrons coming in around the planet. And there's your geosynchronous orbit, 22,236 or 241 miles, whatever number you want to use, plus or minus 5. This is at the lowest energy electron count, meaning that they moving the slowest, these electrons. They have the least amount of energy, and it's recording at 10 keV. This is the highest high energy electrons, which are moving the fastest and zipping around like crazy, and they're recorded at 4,000 keV or 4 MeV. You get the blacks and the purples showing up. You see that line there? That's our false bow shock or magnetopause, which the Earth has had to develop recently, this year anyway, to try to ward off all this backside pressure from Nemesis. Look at it. It's crazy. And you can see the magnetopause gets bent and spaghettied out at times from all that pressure coming from the backside and then the sides as well, apparently. We're not getting much pressure from the sun anymore, that's for sure. Even the solar wind density's down. See the density? I better pull it up on here. Well, actually, it's fairly high, really. I mean, if you looked at some of my earlier vids, the average solar wind densities 4 to 6 atoms per cubic centimeter. So we're still got elevated density levels. Then you got this geospace deal. This is just a different computer model put out by University of Michigan, taking the data from ISWA within that 22,236 mile geosynchronous orbit. You can see the waves coming through, waves of density. Now, I still submit that that's being slung in there from whatever big planet, which was causing up to a 9-hour gap on ACE when it was in front of ACE from collecting data, and as much as a 12 and a half hour gap once it passed ACE and Discover, which was preventing Discover and ACE from relaying their data, mostly Discover from relaying their data to the Earth tracking stations. It's a pretty large planet. So I think when it submitted has a magnetosphere, that's why you get all these splashed out temperature, wind speed, density readings. And I think once in a while, maybe one of their magnetic field lines from that large planet interacts with Earth, and that's why we're getting these fluctuations constantly, because the fluctuations aren't showing up on the ACE or Discover satellites. So let me pull this one through for you. So this is what I'm talking about. These are their planetary magnetic field lines. The blue ones, now those are just supposed to be between the sun and the 9 planets. So we should only have about 9. Well, clearly you can see we got way more than 9, and why are there so many of them bunched up around the Earth? I would submit to you that that's because Nemesis, which has to be back here, emits mostly electrons, the sun emits mostly protons, binary twin, equal and opposite, Newtonian physics. So here's the polar cap field lines, the black ones. Normally they just stream away from the planet. But being that we have so much freaking pressure coming in from behind, they're having to close, that's when they become red, because they reconnect with the Earth to garner some energy, enough energy to expel all this stuff that's trying to hit the planet. Normally they only close right around the poles. That's why they call them polar field caps, these black ones. Whenever they close, that's when you get the auroras. So anyway, look at all the blue. Look at all that violent stuff going on. Oh man, it ain't looking good, guys. Not looking good. Sorry if I'm mumbling. Oh man, I'm running out of time here. I got like 2 minutes left. But you could see the spaghetti-like fashion, and why is this thing getting compressed continually? The solar wind speed and the density numbers don't correspond. So I would submit that that's when the large planet that passed ACE and Discover making some kind of a magnetic field connect with the Earth, or at least helping to push that solar wind speed and make it fluctuate like that toward our planet. So I mean, my hypothesis still stands, and I'd say it's been more bolstered by this information that was able to come up with today. See the solar wind numbers? Crazy numbers. And we've seen them as high as 1,400 kilometers per second, but not lately. It's been about a month ago. So they're back on the rise, and watch these arrows. This indicates the direction of the solar wind speed, the solar wind. Normally it should always be coming from right to left. And as you can see, we got a whole bunch of violent stuff going on back here. The arrows turn toward the planet. That's when you see the solar wind speeds go up. Then they get sort of in a flux position where they get to those little chevrons where it's almost equal. And then, I mean, just look at them. They're getting turned back and forth. So I'm running out of time. I'll post the links. Make sure you hit the description box, pull up the L1 Lagrange point, and especially that space weather tutorial from Solar Ham. Okay, God bless, peace, and